as we'd said, in order to apply the partial fraction decomposition, you have to have a proper fraction. In other words, your rational expression has to have an order on the bottom that is higher than the order on the top. In this case, it's not, right? The order is the same, x squared on top and bottom. In that case, before you go ahead and do the partial fractions, you have to use long division of polynomials to divide this thing out so that you do have the situation where the bottom is a higher order than the top. And I say you have to use long division of polynomials because typically what's going to happen, like I know a lot of you are used to using synthetic division for stuff, but as you know, synthetic division is only good when it's linear factors. And that's not going to be the case here, right? Because it's just from the context, it's going to be some polynomials that you're dividing out, right? So what I'm going to do is I'm going to divide. I'm dividing this polynomial by that one, right? So here's my x squared. I'm going to put the plus 1 over here, and I'm going to divide him by this. This is an easy division, right? How many times does x squared go into x squared? It goes in one time, right? So then I just multiply this down here by 1, x squared minus 2x minus 3. So minus plus plus. I end up with 2x plus 4. So that's my remainder, right? So that means I can write this thing, this rational function, as 1 plus the remainder over my divisor. And now I'm going to do partial fractions with this one. So I'd better go ahead and, yeah, where am I? Yeah, okay, so 2x plus 4 in the top here. And in the bottom, I've got x minus 3 times x plus 1, right? Because I need to factor the bottom. Right. Minus and plus. Yes, that'll give me that. All right. Now I'm going to do partial fractions. So now this is, of course, not a hard partial fractions because all I have is 2 simple linear factors. So it's not going to be that bad. Right, so I've got a over x minus 3 and b over x plus 1. So I put this in here. Make my common denominator. I'm going to get a x plus a plus bx minus 3b here. And so 2x plus 4 is going to be a plus b times x plus my constant terms are a minus 3b. So that's going to give me a plus b equals 2 and a minus 3b equals 4. Okay, so let me just throw through a negative then. Minus plus minus 4b equals minus 2. So b equals negative 1/2. And then, did I do that? Yes, because it's minus, and that guy is then plus. Yep, there we go. That's correct. And so then I have a, let's see, b would, okay, sorry, a would be 2 minus b, so that would be 5/2, right? 2 plus 1/2. Okay, so let us then get our integral in shape here. Make sure we get the right guys here. So this one was 5/2, and this one was -1/2. So I'll do -1/2 there. Okay. Ordinarily I would rewrite it, of course, but again. And then, but don't forget, we had this 1 here. So now I'm actually integrating this. So I end up with x plus 5/2 natural log of x minus 3 minus 1/2 natural log of x plus 1, and then plus a constant. Here we go.